ربنا آتنا من لدنك رحمة وهيئ لنا من أمرنا رشدا فضربنا
So, good morning, everyone. Welcome to this year's pre-conference for AfricaHackOn. There are two concurrent live sessions that are happening right now, of which I'll be moderating this session here. Our presenter today is Amajid Laburam, somebody who is known to the community, somebody who has been doing a lot of work in the space of cybersecurity, and I think you all know him. But I'm not going to spend too much time to introduce him. This session, just want to remind you about what we are trying to achieve here. AfricaHackOn has been running for 8 years now. And I know we have been quiet a bit, but I just want to get you to let you know about some of the new things that are going to be coming. Even though the main conference will be tomorrow, just want to give you some details as to what to expect. So this is the pre-conference. Due to COVID, we couldn't host it physically as we usually do. But now, after this, I believe by next year, we're going to be having a lot of physical sessions. From January, we're going to be having monthly sessions where only a few people will be allowed in. So it will be registration based. And if you register and don't show up, you can't come for the next 2 sessions. That's basically how it's going to be. So this is going to be from next year, from January. We'll be having once a month evening sessions physically, where we'll be discussing all matters cybersecurity. So I'm going to hand over to Amajid, who will introduce himself and take us through the session. Please pay attention. Do have your questions ready and make sure that you can actually engage. Ask all the questions that you can. So Amajid Laburam, I'll let you take over.
Good morning, everyone. I hope you can hear me.
Yes, we can.
All right, just give me 1 second. I'm uploading the slides and then sharing the report to everyone. Then we can proceed from there. Just 1 second.
No problem. Maybe if I could just some comments in the chat session. What are some of I can see if it's true, it's telling us to play the national anthem. Well, not really. It's not necessary right now. Maybe some of your expectations of this session, maybe you can just type them in the chat. Also, if you're logging in from anywhere else in Kenya or outside Kenya, just say hello from where you are. If you can just type in the chat. Where are you logging from? From Ghana? Oh, Christian Kusi. Kusi or Kusi? Kusi or Kusi? Kusi? Anyway, it's good to be here, my fellow Ghanaian brother. Nairobi, where in Nairobi? Sabir and Shalvin. Admin, where in Nairobi? India. Hi, Karan. Nice. I'll see logging in from Kilifi, Wayakiwe, just down the road. From Rwanda, Josie. True in Johannesburg. I didn't know that. That's nice. Indonesia, Kenya, Parklands. It's great to see that we're all from various, from Kayole, from various divisions of this country or this continent. And it's good to just have you all here for this session today.
I'm dropping a link in the chat right now. That's going to be the link to the entire repo that everyone would need for the workshop.
Awesome. Also, just to let you guys know, the recording will be put on our YouTube page later and also on the website, on AfricaHackOn website. And also, I mean, it will be shared around. So don't worry, we're going to share this all around very soon. So Labu, I hand over to you.
Yeah, just cleaning up something and then we can begin.
Okay. Let me check out the link and see what it has.
Yeah, just to verify you can open it on your end.
All right, it's opening. Very
Awesome.
nice. Oh, wow, there's quite a lot to be expected from this. Why so many lab types? And you literally uploaded things 13 seconds ago.
Yeah, I just uploaded my slides 13 seconds ago.
Wow.
Yeah, the slides unfortunately are not complete to what I would have liked, but we will make do with what I have. And as I said, we can always take up questions as we go along.
No problem.
Let me start sharing my screen. Okay, can you see my screen?
Yes, we can.
Awesome. So we'll start off with the slides. Sorry, I have so many things open. Okay, first of all, thank you everyone for joining in today's session. For this pre-conference workshop, we're going to be looking at developing malware, especially when it comes to pen testing and red teaming. A bit about myself. My name's Amajit Laburam. I'm the co-founder and technical director at Macrosec Limited. I'm a cybersecurity researcher. I like looking at a lot of offensive related stuff. So my passion is more related to offensive security. So that's why I focus more on pen testing and red teaming. My other hobbies are farming, fishing, DJing electronic music, and I'm a foodie and a coffee lover. So if you ever meet me outside there, you can always get me a cup of coffee. So what's the workshop guideline for today? The main goals are going to be to create a loader. Basically, that's a little program that will give us control over target or victim machine. And we intend to bypass certain AV engines. And towards the end, we will also look at what's called userland hooking and how one can bypass that. Within the workshop, there's also going to be some exercises that we'll have to perform, and this is going to be hands-on. So I hope most of you have already installed your lab environments. Maybe on the chat, you can just let me know if you have not, because we'll spend maybe about 10 or 15 minutes for anybody who hasn't been able to set up their lab or is having challenges setting up their lab. Then within these exercises and labs, there are going to be some few challenges I've left for you guys to do. So as we go along, I'll expect you to try and do the challenges and enhance your skills as we go along. So we'll start off with an introduction. As I said, the focus of this is going to be on malware development for droppers or loaders. These are what gives us command and control over target victims. So what is command and control? Basically, as per Trend Micro, command and control, also known as CNC or C2 servers, is a computer controlled by an attacker or cyber criminal, which is used to send commands to systems compromised by malware and receive stolen data from the target network. Now you can see from the diagram there is an individual who is sitting out on the cloud, and he can send instructions to the command and control server, which will then send which has some delay time that sends requests back to the target and is able to now either execute further commands or exfiltrate data from that victim machine. So that's just a general gist of how command and control infrastructure would look like. A lot of command and control frameworks that are out there. Some of them are open source, some are paid. So Cobalt Strike is a very well-known paid red teaming and command and control infrastructure. It's got very good reviews and capabilities, and a lot of organizations are using it. In fact, nowadays, a lot of cyber criminals are also using it because it's quite a robust framework. We have other open source frameworks that are shown there, like Metasploit, which I think a lot of people are more aware of. On the right, you have PowerShell Empire, you have Merlin, Slaver C2, Covenant. So there are lots of others. These are not all of them. There are a lot more that are out there, and there's a link at the bottom of that slide to a website called the C2 Matrix. Basically, this is a collection of various so this is basically a collection of various C2 infrastructures or frameworks that are out there, and it's not an exhaustive list, but a lot of insight to the other options that are available. And basically, it even maps out like what sort of infrastructure it runs with. Is it like .NET based? Does it target multiple operating systems, or is it only focused on a specific? So it's a quite nice location or central repository for somebody to go and other command and control frameworks that may be out there. The other thing we're going to look at is just let me know if you've lost me or I'm still on the session.
You're back.
You're back. Okay, so sorry about that. My network, I was just switching the network. Yeah, so as I said, we're going to be focused more on Metasploit. And so the reason for this is because it's a very known command and control framework that's leveraged out there. There are lots of signatures for it as well. So the default payloads get easily caught by most of the antivirus engines that are out there. So the other reasons why I'm going to use Metasploit for this session is because it's able to use DLL injection to load on more modules once you have a command and control session established with a target. And most of these Metasploit modules that come inbuilt with it can run purely in memory without touching disks. So at the end of the day, you're not leaving much artifacts or files for the defenders and incident response teams to, reverse engineer or try and reverse engineer and try and understand what the code is doing. So the other thing that Metasploit also runs, is able to do is it's able to run over TCP and use both HTTP and HTTPS traffic. So you can actually encrypt your traffic if you're running a proper red team engagement. It's definitely advisable to have your C2 infrastructure running with encrypted traffic, so you don't even lose out or people check what sort of data you're removing from the network. Basically, if you look at how Metasploit and the Metasploit sessions run, this is how it would look like on your Kali machine. So to those of you who have never used Metasploit, this is how it looks. And to those of you who are familiar, it's something we all know. So once you have a connection, and we'll be using Metasploit payloads. So once you have a Metasploit session, you'll be able to then directly run some commands or enumeration or load extra commands. We will not be going too deep into the use of Metasploit and Metapreter, but as I said, the focus of this workshop is going to be on getting command and control connection onto your targets. So just the initial bit of getting your session. Then from there, it's up to you to go and read up on what you can do with Metasploit going further. This workshop is going to be focused purely on one particular language. We will use a bit of PowerShell, but then most of it, I think 99% of it is going to be with C#. So we're just going to do a bit of a 101 on what C# is. It's an object-oriented programming language that was released in 2001 as part of the .NET initiative. And it basically compiles into intermediate language, which is then translated by the common language runtime. And you can use both managed and unmanaged code within C#. Now, there's some links that I've put as well in these slides. It's very key for you to go and read them because they'll give you more insight to anything that I may mention and it's not very clear or you need more clarification. You can go and read up more on these things. I'll give a little bit of background between managed and unmanaged code. Basically, that's when managed code is when the runtime environment actually manages the process that is spawned and the memory management for that process. Usually in .NET, that would, as mentioned, would be from the CLR or Common Language Runtime. But what we are trying to do is going to be focused more on unmanaged code. And that means where the programmer is the one who is to manage everything about what the program is going to do. And basically, once the program is launched, the operating system will load that program into memory directly. So it knows, it'll have all the instructions it needs to do in the memory environment. So that's where the unmanaged code comes in, because most of C# is written in a managed code format, I'd say. So this is a brief diagram of how the compiler and the runtime works. So C# and other .NET languages will end up having bytecode that goes into the MSIL, which is the Microsoft Intermediate Language, or the IL code language compiler. After that, it jumps into what's called the JIT, which is the just-in-time compiler, which then converts that code into native code, which now the machine can understand and gets directly executed in the CPU. So this is roughly what we're going to be trying to achieve, is go from C# into machine code language that machine will understand. Of course, we're not going to start writing machine code language in here, but we leverage a lot of Windows 32 API calls to then be able to convert our code and make it into sort of unmanaged, whereby we can actually control the different type of memory processes that our code will interact with. So this is just a basic example. As always, when it comes to programming languages, the first thing we always learn to do is, print hello world. So this is a structure of how the C# language sort of looks. You can see at the beginning, we have namespaces. So like using system, this is where now the different functions are called for. For example, in this one, we want to write console write line hello world. So basically that means we're going to leverage the system namespace, which loads all the required libraries and functions that we need to run the console.write line. We have a class that will hold all our code into, and basically the main is where our program executes from. So it knows this is the segment where our code is supposed to be looked into. In between, before the class, this area, usually we can have declared variables and delegates and other things there. So this is just a simple, hello world sort of example. It's part of the lab or lab one bit, so we will get to that when we're in the actual hands-on segment of the session. As mentioned, we will be trying to leverage unmanaged code or migrate from managed to unmanaged compilation for our programs. So basically with that, we will be leveraging the platform invocation services, or known commonly as pinvoke. This allows us to use unmanaged library, which are just DLLs. And it also requires the namespace system runtime interrupt services for us to then be able to link to these unmanaged DLLs and call for those specific functions that we want from within those DLLs. So we get into the labs. The first lab was basically the environment setup. I know we have 70 participants based on what I can see there. How many of you have got their labs up and running? I can see Jane, one of the admins, and Sumyajit has it done. That's just 3 people. Maybe, I don't know, how can I do this? Is there a way of using show of hands or something in Zoom? Okay, so Christian, you're asking for Kali. I think if you read the Lab 0 guideline, which is on the site, if you go to the link that was shared. If you go to Lab Guide 0, there's a brief on how to set up your, for those of you who didn't get to see this, this was actually released a few days back. For the Kali, you simply just download Kali VM, but you will need to go and set up VirtualBox configuration. If you're using VirtualBox, that's for the people using VirtualBox. There's a configuration setup that's there so that your Windows development environment as well as the Kali machine can communicate to one another. So you need to set up the network with these sort of adapter settings. As I said, it's available in the Lab 0 guide. And you'll have to also configure static IP on the second Ethernet, because I said, as per the way this lab has been set up, I have adapter 2 that's set up to communicate within the internal lab, which comes down to Ethernet 1 connection on your Kali, on the Kali machine. So you will need to set this up at least beforehand. And okay, so mine's not ready. For those of you who are saying not ready, can we give you at least 10 to 15 minutes to get that set up so that we can then resume the lab sessions? $10 minutes. Is that good with everyone? No, you don't have to use Kali. I mean, you can use any Debian-based operating Linux flavor, but the key thing is because we're using Metasploit for the walkthrough of this labs. Kali comes with Metasploit already built in, but if you're using Ubuntu, Debian, yeah, Debian works. Anything that's Debian-based and you can have Metasploit running, that works. Or even there's some people who run Metasploit on Windows. So if you're one of those guys, feel free, just know that you need to have one machine running Metasploit, and you'll have your target machine, which is the same as the development environment, which I've already shared for you to install. So I'll give guys 10 minutes. It's currently 10:26 where I am. So can we say we'll continue at 10:35 in 9 minutes? And for those of you who have any questions, you can already start firing questions my way, and we'll try and answer them. To those questions that may have answers ahead, I'll leave them to till when we get to that part of the session. File location, I think it was already posted, but I'll just share it again. No, this is not going to be a beginner series. If you go to the lab workshop, there's a little bit of information about what we're going to be doing. And we will be looking, you will need at least some intermediate skills, but I mean, it's not that difficult. If you can understand a bit of programming and scripting, it's quite easy to follow along. But yeah, it's up to your how good you are at certain tasks and functions. And as I said, if you already have C# experience, then it'll definitely be a bonus for you. So Karen, you've asked, yes, PowerShell is being caught nowadays in enterprise environments. Is there anything apart from C# and WMI which operators use to move stealthily into networks? So personally, I don't even use C# and PowerShell for my initial droppers. This is the first time I was working with C# just to understand how to leverage the same techniques that I use in other languages. But basically, you can have your initial dropper in a different language like C++ or C. But to get your code down onto your target machine will mean that you have to come up with some creative ways of then getting your code there and running. And yes, as PowerShell is being heavily observed nowadays because of how much it was being misused back, I think in between 2012 and 2015, 16 there. So it's not as easy, but it's still usable. It's not dead. It's about now how you can operate. That's why I said something that was introduced. It's not in the slides, so I can discuss about this. In, I think, 2018 or 19, Microsoft introduced what's called the Anti-Malware Scan Interface, or otherwise known as Amsi, which basically plugged into that region we call the CLR, Common Language Runtime Engine. And it would be able to look at the type of code that is being executed in that CLR region. And if it noted that it was anything malicious or had signatures, then it would get caught. So eventually, people had to now start looking into how to bypass Amsi. So there are ways of getting around Amsi. It's now, again, on the operator to understand, again, which Amsi they're also dealing with, because after C# started getting leveraged from 2016, 17 there more heavily, Microsoft then also got Amsi to be able to detect C# based code. So basic, those fileless executions and stuff like that in memory are still observed. Usually Amsi operates in the memory region and memory space. So it's anything that's going to be executed in memory is what Amsi will scan through. And if you can look into the different types of Amsi options, how would I say it? Not options, but sorry, the right choice of words slipped my mind. But basically, there is an Amsi for PowerShell, and then there is also Amsi based on the process that it's running at. So you can bypass Amsi PowerShell, but still Amsi is running in the context of your current thread. Or you have the option of bypassing Amsi completely in your thread. That means then you'll be able to even leverage C# code. One of the tasks that is in the workshop, I think one of the last tasks, involves a bit of that. So you'll come into that. So I saw your post, make FUD mark mistake. It's very useful. Still many we can't catch it. Thank you. At least that I think one of my colleagues is the one who did that. That's Varun. And we have some other ones that we've been making. I mean, we enjoy developing malware, so this is something we do at our organization. if I have a VPN, is it okay to use my network lab? Yeah, I mean, however your setup is, as long as you can communicate between your command and control server and your development environment, feel free to set up your environment to your liking. I have a Windows 10 Pro on my VM. Can I use it and need to have enterprise version? Yes, you can use your whatever you already have. But as you saw on the document in Lab 0, there are certain tools you'll need to install onto it. So you'll have to install Visual Studio, Notepad or Sublime. It's Notepad++ or Sublime Text as your preferred IDE editor. You'll also need to install DNSpy, Confuser X, and Process Hacker 2. So you can again go back to Lab 0, go through the document and see what you need to install your stuff. That goes out to David Thumbi. Finally, an African red team I can thank you. You're welcome. The others, I'm not the only one. There are quite a number of us out there. I know a couple of guys out in Ghana. I know a couple of guys locally as well. So yeah, we're a number of us, but it's nice to know there are people who are looking for more of us. Okay, good. Carly is up. We have another red teamer who's speaking here. So yes, that's true. I don't know why they don't get respect. I don't think I get much respect either as well. Yay, we have somebody who is very key to this talk as well, joined in. That's Jean-Francois. In fact, if you go to the acknowledgement section, you can see he's referenced there. So that's somebody I really recommend guys to follow. Check out his streams, check out his videos. He has fantastic content on red teaming, and I always learn whenever I read his stuff. So please, guys, check out these links that I've shared here. They'll definitely guide you to other things. As I said, when I started this project, I'm not the best in C#, but I was just going through it. I understand scripting, so it was pretty easy for me. And all this started by just going through people's GitHub repositories. Of course, a couple of Stack Overflow questions here and there. And definitely these guys and their different repos have helped out build what we have as our labs for today. Okay, so we have about a minute remaining. How many of you are all set up? Okay. And okay, so we have one done. Is the audio bad, or can you guys hear me? Just somebody say it in the chat.
We can hear you really clearly.
All right. Oh yes, the Sector 7 course on malware. I did the intro one. I think the first one that he had released out back in 2019. It was actually a major boost for me as well to understand how to implement various ways of running your shellcode, through the header files and stuff like that. Though that's more, I think, focused C++, and I am actually from the C++ background. So for me, it was quite easy to understand. Yeah, why go from C++ to C#? I mean, it was just to understand a different programming language, and I see a lot of people developing tools in C#. So for me, it was just to understand how C# works and leveraging the fileless stuff, with system.reflection assembly and other fileless ways of running your code. So for me, it was more of that. Why go there? Because fileless pre-BOFs. First of all, I don't have a Cobalt Strike license, so BOFs is completely out of my budget line, I'd say, to have. And yeah, Vince, there's a reason you were blocked by Paranoid. Okay, so yeah, Liam knows what you did. We all know what you did. All right, so I think we'll get back to, I think we have seen a couple of people who have their apps done. Sorry? So it seems like a number of people were blocked by him. For those of you who may not be aware of what we're talking about, this is just Twitter rant and red team rantings. So yeah, don't worry about that. Yes, Sumyajit, you've dropped a couple of interesting organizations that have red teaming courses. I'm currently doing the red team operative at 0 Point Security by Rastamouse. So that's something I also highly recommend to people. It's quite, the structure for the course is quite straightforward and easy to digest. And it's beginner friendly. It's not too deep into the concepts of red teaming, but at least it'll give you an all-round start off to everything you need. Yeah, that's just Combo Strike within the lab ranges. Yeah, and then I definitely have mad respect for the guys at Fortinote because they have some interesting courses on initial access. So sort of like what we're doing, but we're just creating a dropper. They go to the extent of weaponizing maldocs, and I think they came out with a very interesting tool 2 years ago called Excellent Donut, and I think Hot Machengo, which I really liked. Dark Vortex definitely is also another institution. And of course, the Spectre Ops, there is a Trusted Sec where Jean-Francois works at, and of course, MDSec as well. MDSec is from the UK, run by Dominic Shell. I hope I didn't butcher his name, Dom Shell. And they also have some very interesting TTPs, that's tactics, techniques, and procedures that red teamers and threat actors can leverage. And I've seen some mad stuff that they've released over the years, especially hiring guys like Batsec, who is super young but has some extreme skill sets. Without Spectre Ops, of course, yes, Spectre Ops are the people who are behind Bloodhound. I think I've forgotten the guys' names. There were 3 guys. There's Waldo. I forget their names, but yeah, they're the people who are behind Bloodhound, which is a very key tool that people use for mapping out attack paths in Active Directory environments. So definitely when you're doing your red teaming to courses and you're getting into Active Directory, you will definitely hear of Bloodhound. Okay, cool. So let's just get back to we'll end up just talking throughout this. Yeah, where's the labs? There you go. So yeah, lab 0 was just environment. So we'll start with lab 1. So the first thing we're going to look at is the console class. And basically, as you saw in the Hello World program example, the console class represents a standard input, output, and error stream for any console application. So when we're running and we want to print Hello World, you can just simply put console write line and open brackets, and you can put your whatever text you'd like printed out within the quotation marks. And then if you put the console read key, that will hold the console open until a key is pressed for it to continue running. So some of the things that we're going to do is we're going to try and also look at, we're going to interact as I mentioned earlier, using the platform invoke. we're going to try and engage with the Windows API. And of course, what is the Windows API? It basically exposes programming interfaces to services provided by the operating system. So for the instance, when we want to run something like a message box, we will have to call certain Windows 32 APIs that have that message box functionality, and then input that into our code, and using platform invoke, leverage that to run the message box and pop it. So basically the Windows 32 API gives us a lot of leeway into the operating system to things like file systems, processes, thread management, network connections, user interfaces, and more. You can read more about this on the link that's on the slide. Basically, this is what I mentioned earlier, that leveraging the Windows 32 API, we can have an application that when it requests for a specific, for example, the one we used for the message box, it will go and look at the kernel 32 DLL for that specific function and map it and ask for that function to be brought to us for us to then run our code. All that will do is before it can go and communicate with the kernel, which is the low end of the operating system. So usually we operate at what's known as user space, and kernel is where now that's going down to the hardware level of the machine. So when we want to leverage something that's going to be in the kernel level, there's usually a DLL called NTDLL that maps certain syscalls that will then go into the NTOS kernel EXE, that's at the kernel level, and map out the specific syscalls that we're trying to look for, bring it back and compile and interpret whatever program we're trying to use and give us access to that Windows 32 API that we're looking for. So basically, this is sort of the general flow of how the calls would be made when we're leveraging unmanaged code, because we need to use syscalls when we're running unmanaged code. So again, that's just another breakdown that .NET application uses standard user mode EXEs. It'll also use standard user mode DLLs. But then we want to use unmanaged code, so we have to use COM servers to then load our Windows API DLLs, which will then give us access to the Windows kernel to pull out those specific APIs that we want to utilize. So the example we talked about is the message box. Basically, this displays a module dialog box that contains a system icon, a set of buttons. This is just picked out from the MSDN Microsoft documents. So you can go and check out more details about what this function does. And the syntax is in C++, but again, when using C#, we can definitely get the same, because the key thing we need to do is we need to get these functions, these variables created within our function call that we want to use. So before we end this lab, maybe we can go to the practical side of things. So to those of you who have your labs set up, the first thing we're going to do, and this is now where you're going to follow the the main lab guidelines, which are, keep closing that. So for those of you who have your labs set up, you can open the main lab workshop guide and we can start off from there. So to begin with, we'll just make everything easy for us by disabling antivirus. That means disable real-time protection and cloud delivered protection. We'll understand a little bit more about it as we go along. And if you can try and copy the labs onto your Windows environment, so you can download it just by following the manual that's there. Once you've downloaded it, unzip it and put it in the weaponized folder. For those of you who are using the VM that I created, the folder weaponized on your desktop has been excluded from Microsoft Defender scanning it. So at least it will lessen your issues and headaches with it, at least to compile and run your projects. And the other thing is, for those of you who haven't, you need to create a folder. For those of you who are using your own VMs, not the one that was provided, you need to set up at least a folder that does not have, that is excluded from scanning from Windows Defender, so that you can open the files without having issues, because some of them have raw shellcode that's not obfuscated. So even just opening it in Notepad++ will start triggering Defender. So that's the other reason why I just disable it for now, but we'll enable it as we go along, because after all, this whole workshop is about trying to bypass antivirus. So the first exercise we're going to do, for those of you who have never used Visual Studio, the developer command prompt for Visual Studio, that's what we'll be using to compile our code. So we're not going to be using the Visual Studio development environment, but just the developer command prompt to compile our code. So you can just follow the commands that are given there. So I'll just do that on my side. So as I said, there's the weaponized folder. I have the zip folder and I've unzipped it here. And under the labs, we're starting off with the first lab, which is introduction. And we have two files. There's a program1 and a program2.cs. So we'll be opening the first one. Let me just close all these out. Sorry. Yeah, so the first one we're doing is the hello world example. And to be able to compile this using the .NET, using the development command prompt, you just simply open it. And we can cd to that specific directory. The command prompt, so you have to use exclamation marks. So once we're in that directory, sorry, I'm using PowerShell command prompt to do this. Yeah, so to compile, you simply just use csc.exe and then the program1.cs. And if everything goes well, we should not have any errors, and a new program file will be created. And if we do dir, you can see it's 10:49 right now, and we have a program1 file that has been created. So if I go there and open this program1 application, you can see our hello world is printed out, and then it says press any key to exit. The reason for the press any key to exit is because we have the console read key set. So until we press any key, it will then it won't return until it will not end the application until that function has been returned. So when you press enter, it goes, and that's basically your first hello world application in C#. So we'll open the next file, which is the program2 file. Now this one this is the one for message box. So as mentioned earlier, this has, I don't know if it's very visible, or hope that's clear. So we have added a namespace over here for pop message. I'll explain the reason why I did this. You don't really need it for just doing a simple pop, but then I wanted to show also using PowerShell how you can execute filelessly. So that's the reason why, that's the reason I put the namespace. And then you have the program, the class, which is called program. And now the first thing we're going to do is we're going to import the user32 DLL, because we want to import the message box function from this user32 DLL. And as we saw in the slide, the message box function has sorry, I have things just moving around. Okay, there we go. Yeah, so as we said, we had based on the syntax we've seen, there are 4 parameters that will need to be supplied to the message box function. And if you look at our code, we have those 4 different. We have the 4 different parameters stated out here. So if you look at our function now being called within the main part of the program, you can see there's a pointer 0 that's pointing to the first parameter. The string text is this one, which is find the DLL import. The string caption is basically the title of the message box, which is the just popped. And then we'll just pass in a 0 pointer to the last value. And if we compile this, again, we'll use CSC to compile. So we'll just be using CSC for all our compilations for the code that we're going to be using. If you do dir and you go to, you'll see there's a program 2, 1052, which is our time. And this time, if I open program 2 from here, we can see the message box has popped with the title just popped and the text find the DLL import. So if you look at this, this is what I said, the title just popped, which is the string caption variable, and the string text is the find DLL. Find the DLL import a string text. So if you click OK, it closes and all that. So that's pretty much well and good about getting that message box to pop. And we're going to look at the next thing we're going to do with the lab. So yeah, this is what we've just done, the second exercise, which was to pop the message. As I mentioned, the reason I put the namespace is because I want to use the system reflection assembly function in PowerShell to reflectively load this, the assembly without having to touch disk. So what you need to do to do that bit of the lab exercise, which comes into lab exercise 3, we have a PowerShell Cradle that's in our lab 1 folder. If you open that in, if you open that in Notepad, this is basically how it looks like. There's an Amsi bypass there. As I mentioned, Amsi is something that works when it comes to execution of PowerShell and C# or anything that's trying to operate in memory and leveraging on the command, either the CLR or JIT. So what happens here is now you'll have to bypass Amsi for you to be able to execute your code directly in memory. This being a very simple program, I don't think it should get flagged per se. So even if you don't have the Amsi bypass within it, it should work. But basically, we're going to take that program 2 we've just compiled, the message box 1, and you notice that the namespace is called here when you look at the entry point method. So we call the namespace and the class, the program class for where all our code is. And from there, it knows that it will use the string arguments, which is the main function, to invoke our application. So this is the Cradle that we will use. Now you need to transfer this as well as program 2, the one which you've compiled, onto your Kali machine or your attacker infrastructure. So I didn't do this earlier in the labs, but you can do this yourselves. What I'd suggest is just share your weaponized folder. So right click on it, go to properties, sharing, share it, make sure it's shareable and it's shared to everyone and give them read-write access. Of course, it's not something I suggest to do in a production environment. This is just for us to make sure we get our files. So that's done. You can do advanced sharing. Make sure permissions are set to everyone and they have full control. Once you have that ready, you can go to your Kali machine. So on your Kali machine, you can, sorry. You can browse to your network and just type here SMB and then the IP for your Windows machine. If you've set it up initially, it will ask you for a username and password. Use the username and password for your Windows machine. Once you have access, you'll be able to access the different drives. So as I mentioned, I need you to get the files that's the cradle and the program2 executable. Copy these to your root directory. So I'll just remove these two. I'll verify that this is still set to everything. Yep, so that's okay. Now this side, we can close things up. Now, what we'll do is we'll just open a new command prompt and go to our root folder. You can see the Cradle file is ready and the program2 file is there. So we'll spin up a simple HTTP server. On port 80, it doesn't ask too much. Oh, okay, I have it running already somewhere, so just give me 1 sec, I close that. Okay, it's here. Yeah, so once that is running, to verify that this exists, you can use Microsoft Edge and just browse to that IP. And as you can see, it lists, so that means we should be able to access the files that are there. Yeah, we have Cradle and all that. Okay, so that's cool. So another thing, if it's your first time running, if it's a very clean new Windows VM, sometimes if you're running PowerShell Cradle scripts, it might give you an error because Internet Explorer is not yet configured. So for those of you who are doing that, just open Internet Explorer, not Microsoft Edge, but Internet Explorer. And as the guide says, just go through the configuration setting. You can say do not, I believe it's do not, do not use recommended settings. And then once we're done, we can now use this PowerShell script to launch our message box. So let's go ahead and do that. So I already have the command here, Cradle. If I open this just to see what files get pulled down, close this to clear out a bit of space. I click OK, you can see the files were pulled and the message is popped. So basically, our program2.exe has been executed within PowerShell. If we have, of course, I wish I had started this. No, actually, I think I had it running, but yeah, you need to run process hacker. We'll need to have this started so that we can see the various processes that get spawned. And yeah, sorry, that needs to be open. Close this. So yeah, you can see we have a PowerShell prompt here, and it's the one which was spawned and popped that message box that we got here. So basically, that's how you can be able to leverage the system.reflection.assembly to execute your C# binary filelessly in memory without having to actually drop onto disk of your target machine. There's some exercises we'll do further that will involve you modifying the cradle.ps1 file for you to be able to be able to do this, the next exercise, or at least the final exercise, filelessly. So with that ends this section of the exercise. Let's see what the lab guide says. Yeah, so once we've invoked, as you saw, it popped under PowerShell. Now, one thing about C# is that it's easily reverse engineered. So you can use certain decompilers that can be able to translate and see the bytecode more or less as clean as source code. And we have dnspy installed on this box. So we will use that to read through our program 2.exe, the message box one. Sorry. So that guy, open dnspy. So this is why I was saying if a file is then dropped to disk, somebody can go and decompile it, and I mean not decompile it, but use it. Yeah, exactly. Decompile it and read through it and see if they can see the source code that's in your code. So going back to the lab one, we'll just pick program 2, drop it here. So once you have that, you can open the tree. When you come to PE, I think, no, sorry, when you come to pop message here, let's see. Yeah. So when you come to pop message under program, you can actually see our source code quite clearly visible. So if you compare that with the one we have in our notepad document, sorry, you can see the different namespaces that are being called, the system and system runtime interop. You have the namespace pop message. So basically it's clear text of our compiled code. Now, as an attacker, if you don't want this to happen, one thing you can try and leverage is obfuscation of your code. There's a tool called Confuser X. So in fact, what I'll do, I let you guys do that next bit of the lab, which is this part, running your program through Confuser X and getting an output and seeing if you can decompile your program. So maybe I can give you guys 10 minutes to do that. Will that be okay? While I also take up any questions asked in the chat. For those of you who talk of the Cobalt Strike cracked versions, I'd be careful with those. They might have, I mean, there's actually even a blog by Ralph March, the guy who wrote Cobalt Strike, about how to backdoor the application itself, because I think it uses Java. So there's ways of backdooring it and redistributing it. So you might be running a C2 server that's already backdoored. So I wouldn't recommend you, if you're using for a legit client sort of scenario, I don't think you'd want to run those cracked versions in your red team engagements. Without spec drops, we wouldn't have that down. Yeah, we read that. I treat the chat like, yeah, that's true. They did what's up for African red teamers. I don't think there is one, but we do have a Discord for a red team lab by Alim. I don't know if it's the same one that Vince has put there, but yeah, check it out. It's Alim is a fellow red teamer from Kenya who sets up AD or forests and I mean AD labs that are insanely challenging. Well, at least for me personally, but they have made me learn a lot as I've gone along, and especially if you like challenges that make you cry premium tears, definitely worth checking out. Yes, we will be moving from P invoke to D invoke by the end of this workshop, so don't worry, hold your horses, we will get there. Too many tabs, I guess we're the same. Yeah, I have a big let's say pain point, not pain, but a problem with not closing tabs. So I have tons of tabs always open, and it's always things I think I need to go back and read to. Playing awesome AD labs where, yes, that's the one I was talking about, Alim's, so you should be able to access them. Okay, there's a video. Yes, now you know. Hello world, time for syscalls. The first syscall we did was just message box, using message box. What IP is that, please? Why would you want to do that, Jean? Everything looks so nice. I need to clearly upgrade. Yeah, I'm actually that's an old Kali VM. I've just been upgrading it. So, but I think it's running Kali 2021.3 right now. Not too sure. You can just use basic parsing. Yes, you can. So for those of you who are, if the Internet Explorer thing was giving you a problem, you can also use this command within your PowerShell script. I mean, not script, but in your PowerShell launcher, IEX Cradle script, to then bypass the whole thing of making sure that Internet Explorer is fully configured. Yeah, Process Hacker died, and I think they launched Process Hacker 3, which had some weird ass interface. I still prefer the old one, so I stick to that one. Oh, there's some other ones I'll check out. Thanks, Jean. I'll definitely check these out. No, not that. So this is basically for, so good. Now that means we have an extra challenge for that will come later. So once we have used Confuser X to compile our code and hide it, then probably use no Fuser X to then see if we can read our messages again. Defender. A person who has to be a red teamer but has no idea where to start from. The field of red teaming, I mean, there's lots of areas you can look at, because I believe red teaming does not just mean knowing one specific like way of how would I say, just like Windows system. I mean, there's areas like DevOps side as well, because your infrastructure, managing all that is part of also what a red team operator needs to know. The malware development is a whole chapter of its own, understanding Active Directory, understanding the operating system. So as somebody who's just like maybe starting out, I would say, first of all, reach out to people on the Twitter and in the community. I have put some names in this workshop reference. So in the acknowledgement section, so some of people you can follow and reach out. A lot of them are usually quite friendly. I know Gene is, so you can reach out to him. He'll probably be able to guide you or help you out with the challenges you're facing. So yeah, just reach out and then try out things that you like. As I said, personally, I've done AD based pen testing and red teaming, but a lot of my time I spend is on the malware, especially the dropper side of things, and just developing weird ass droppers around in different languages, actually. Yeah. So find what you enjoy and focus and become really good at it. Then maybe progress to another branch of red teaming and then do the same there. So that's how I've been growing myself. Claudius, watch YouTube. Of course, yes, that's as Gina said. Read the blogs. Internet when you speak in workshop and a demo attendees to know what I just don't. They want to jump all over the basics and start. Yeah, that's another thing. Everyone will always want to do those kind of things. Internals before red teaming, internal pest, exactly. So Jean has given some really good advice. I should have read these before even opening my mouth. Red teaming, the internals. Yeah, as I said, just make sure you understand what you're doing. So maybe to clarify on what also the internal versus red teaming is, the difference between an internal pen tester and red teaming is just the nuance of knowing how EDRs work and how to exploit the blind spot. I don't know, maybe something to add to the red teamer side versus the internal pen test side is, again, usually I've had a lot of people asking me, oh, I want to get a red team, operation done. But then when you ask them, like, what sort of defense mechanisms do you have on your end? They're like, oh, we're just running a firewall and a basic antivirus. So you're like, then what exactly are we testing as a red team? Why don't we just do a pen test? Because at the end of the day, a red team is supposed to give you value for money for what you put in your defense side of things. Exactly. Red teaming without a blue team is basically useless. So I always tell people, before you try and understand also the terminologies, because sometimes your clients are also misguided and just want to use buzzwords. So just be careful when you're dealing with them, and also you also understand the difference between the two. Because usually when I talk of red teaming, I'll look at focused on what are the blue team or what are the defensive abilities that I'm going against, so that I can see how I can showcase if there are any pain points that are possibly exploitable, or if not, is it configured the right way to even just see if a basic attack is going to be detected. So again, red teaming is not always about just bypassing the defenses and saying it's a win. It's always good to also have your client environment giving reports that you have been detected. So even if the blue side has a win there, it's at the end of the day, it's for the benefit of the client. So it's a win for them. Should one be focused on CTFs or concentrate on MITRE ATT&CK? CTFs are really good. I started off from the CTF side of things. Actually, I have a CTF. One of the AfricaHackOn CTF challenges is by myself. So I still do dabble in CTFs once in a while, because not all environments are going to give you real world sort of scenarios. But I've noticed a lot of platforms have started picking up challenges that are more real world related. And I still encourage people to look into CTFs. But then also, if you want to get into the red teaming side of things, as Jean put out clearly, follow various red teamers on Twitter, check out their blog posts, check out the conferences and workshops that they have, because they're not going to be stuff that's going to, you'll get exposed to very easily in CTFs. But as I mentioned also earlier, Aleem has Active Directory labs. So again, at least if you're going to be focused on things that would be red teaming AD related, you can always learn a thing or two by doing his sort of CTF platforms. I believe he also has an AD CTF challenge in the AfricaHackOn CTF this time around. So yeah, we are trying to also implement real world sort of scenarios in the CTF challenges that we set up. Cool. I believe that should be time for the first bit of this. Oh, you're most welcome, Aleem. Thank you for doing all the great work you do, because, I mean, it's free. That's the other thing. Guys, listen, it's a free AD lab to test. So for those of you who say, oh, I don't have resources to build an AD lab and all, if you really want to push your mental capacity, attack Aleem's labs. Trust me, you'll enjoy. Okay, so let me just get back to the presentation. So the second lab we're going to look at is creating a simple shellcode runner. So what are we going to be dealing with? So we're going to be using Metasploit staged payloads. And basically a staged payload means it's a very small bit of the entire payload that's sent to the target, as you can see in the image there, that's sent to the target machine. And then the target machine, once that gets executed, the target machine will go and pull down the rest of the payload and execute. And once that executes, you should be able to have full command and control shell or interactive command and control Metasploit session enabled. We will, as I said, because of using Metasploit, we'll be leveraging MSF Venom to generate a payload or shellcode. And what is a shellcode? So basically, shellcode is a sequence of bytes that represent assembly instructions. And those instructions are now going to be having, will be the one that will, when executed, will then request for the rest of the payload to be pulled from the command and control server. And once it successfully executes, you should then be able to get a shell onto your target machine. And as I mentioned earlier, we're going to be using MSF Venom to generate, or rather, I mean, MSF Venom can be used to generate various types of payloads. So aside from just like this one will just generate an executable, and it'll be called reverse shell.exe. Well, in this example here, you can see that it generates a byte array, and this is for C#, which is basically what we will be leveraging. So MSF Venom has also other various languages. I think you can do for C, PowerShell, C++, and other things. I mean, you can go and play around with it, check it out, see what you can do with it, right? So Shellcode Injection. We're going to leverage three main Windows 32 APIs to achieve our shellcode injection. And that's going to be virtual alloc, create thread, and wait for single object. And the screenshot you can see here is actually from the program, from our lab code. So I have added some comments in the code, as well as some console write lines, so that we can understand, or when the code actually executes, we can have something to visually see and like understand what we're trying to do. But you don't need to have these two lines in your code. Basically, the main thing is like the virtual alloc here, the marshal copy, and the create thread, and the wait single. So the commented bits are not really, and the console write lines are not really things you need in your code. Sorry. So if we compiled the lab2 program file and we ran it, you'll be able to see that it will execute, and this is of course with antivirus turned off. It'll execute and it'll create a thread within itself, and we can get a meta session. So we will switch to our, the development. Before we do that, actually, let's just go through the different Windows 32 APIs that we will need. So what are these APIs? As we mentioned, we need virtual alloc, create thread, and wait for single object to be able to achieve this. So what does virtual alloc do? It basically reserves, commits, or changes the state of a region or pages of virtual address space of the calling process. So basically, this is the memory region that we want to inject our shellcode into. So it will reserve or commit a specific, as you can see, the 4 different parameters that it passes needs. There's one that has size. So it'll be able to tell how much size it needs to reserve for our shellcode. So that's what the virtual alloc does. Now we'll leverage the Marshal class that uses the namespace system runtime interop services to be able to copy our shellcode into that memory region that we reserved with the virtual alloc with virtual alloc. And then we will use the create thread function to execute within that specific virtual address. When that thread is executed, it will execute our shellcode, right? And then we use the wait for single object function to make sure that everything has completed running before exiting out of the application, because you might find that if you run your, the previous command, the create, before maybe even the Marshal copy is completed, you might find that your entire shellcode was not copied into that memory region, and therefore it does not execute properly. So with that out of the way, we can go and into our lab environments and do that. So again, we will look at our docs. So I hope all of you were able to check out how your code would have looked like when you opened it in DNSpy. And as we saw, there's no confuser X, which we can then use to then reread whatever was compiled through Confuser X. So that's something I'll use as an assignment for myself to do later. So first off, we need to, of course, create our MSF Venom payload. And of course, since we're using C#, we want to output it into C#. So this. Should always have cheat sheets. So basically, we're going to use the Metasploit reverse TCP payload for Windows x64. Our target is x64. We give it the IP for our listening host, which will be our command and control server itself, and the port we want to open for the connection to come through. We're going to use the exit function thread because we want that when that code exits, it does not kill the thread, and you can have another thread running on the same port, and it's C# based. So we have our code being spat out by MSF Venom. Once you have that, once you run this, it will give you a chunk of code. It might not look very clear here, but basically we're going to copy this and replace this whole section till here. Now, something to note, this might mean you need a bit of notepad kung fu. I know, is that the right word? Yeah. Let me open this as a new. No, actually, it's clean, so it's okay. So basically, you're going to copy this into your program in lab 2. And we're going to replace this segment with what we've just generated. Once you have that ready, I've commented out the command. So as I said, I'll just read through. There's a bit of a brief of what the program does, what is and the different Win32 APIs it's going to request for. So leveraging kernel 32 DLL, we're going to look for virtual alloc, create thread, and wait for string object. You can see here we have used the pinvoke to map out the kernel 32 DLL and get the actual function that we want from it, which is the virtual alloc x, and the different parameters that it needs to be assigned for it to work. So the same and Windows documents that point to the specific syscall that we're looking for, or function that we're looking for, sorry. So with that, then we have the next part that holds our actual bytecode, which is the shellcode that we generated. And from there, we can see, just like in the screenshot that was shared in the slides, we'll then allocate memory for the shellcode, reserve it, and using execute read write permission, which is something which is a no-no. I mean, if somebody EDR sees that, it's just going to flag out because it knows that this sort of memory regions are where malware creators tend to execute code from. So you don't want any memory region to be on read write execute. It'll either be in read write and then in read write and read execute mode. Don't quote me on that one, but yeah, you cannot have it on all three, read write execute, because that's just a red flag for malicious activity happening. So once that is done, virtual alloc to those specific regions and the memory spaces that we talked about. And then we do the marshal copy into that memory space, which is we're copying our shellcode. And from there, we then leverage the create thread. So we're going to create a new thread within that process and execute it. So when that executes, we will use the wait for single object thread so that it does not kill it before the whole thread has completed executing of the shellcode. So we can compile this. Again, as I said, we will use CSC. So we'll switch to that lab 2 folder. C1. We compile that. Everything should, whoa, okay. Okay, what's using it? Can I just close these, close this. Data protection is turned off. Add that, that, no. Okay. Okay, so once that is compiled, just make this slightly smaller so that we can have. So to be able to catch our reverse shell, we need to then have MSF console running using the exploit multi-handler exploit. And we have to set the payload to the same one that we generated, which was the x64 Metasploit reverse TCP, with the same parameters of the IP and port and the exit function. And we'll just run the exploit -j so that it runs as a background job, and we can just keep on getting shells. But before you do this, if you've just launched your Kali and you've not launched it before, since we're using the stage Metasploit, it's good. It requires a link to the Postgres SQL database. So also just make sure the Postgres service is running. We can do that quickly. If it's not, you can just start it up by doing start, and it should be up and running. Once you have that running, we can use the MSF console command and set up our listener. Let me just quickly read through what may be there. Sending UPT assessments. Are macro attacks dead? No, macro attacks are not dead. Doing macros wrong. Yeah, well, at least I know with the XL 4.0 is no more, with the new updates and patches for Office, I don't think you'll be able to run XL 4.0 macro attacks. But yeah, it depends on how you're leveraging it. And there's a group of guys, I think they call them themselves the Adepts. Wait, let me just get the name. They have some mad stuff on VBA and macros and leveraging it from Office. They called what? Yeah, Adepts of OXCC. They do some real. They have some. Yeah, Snoopy Owl, these guys. They have some insane stuff you can check out, and they go into like actually using syscalls within VBA and all that. So definitely check their stuff out as well and their blog posts. I don't know why this doesn't have much, but I think if you follow their Twitter handle, they release quite a number of stuff on it. So definitely check it out. Still fire, you might need to tweak the macros. Of course, yes, that's part of it. Still use it. JavaScript. Yeah, exactly. Yeah, as Ali mentioned, so something that came out this week is apparently JavaScript has been there, but then they're like enforcing it fully now into Office. So that's something interesting. Yeah, as I mentioned earlier, Excel 4.2 will not be able to be leveraged in updated versions. Yeah, it's JavaScript, not Java. Yeah. Because of that, Shellcode, we got you to JS. Yeah, okay, you don't need just return to the UID track. I just don't want those errors popping out every time. It's not something you definitely need, but yeah, it just makes your workflow easier, cleaner. Okay, so we have the lab 2 compiled. We'll now try and launch it and see if we can get a shell on our Kali machine. So we come to labs, lab 2, that's the one, 1127, that's right now. If I run this, you can see it's ascending the stage. So it initially did the initial stage was launched. It went and pulled the rest of the payload from the server, executed, and we have a session opened. So if we just do sessions minus I1 sysinfo, get system information of our machine, get UID, will tell us who we're logged in as, which is what we need here, is 5508. So if I just do PS, because I know we've launched it as program 1.exe, you can see the process ID for program 1.exe is 5508, which corresponds to our current session. So basically our shellcode is running within the program itself. So it's created, it used virtual alloc to create memory space within itself, Marshall copy to put the shellcode into that memory space, and then created that thread and ran it, and that's what executed our shellcode. So that's the workflow around that lab 2. This will stay open as long as this window is this pop-up window. If the user closes this, you'll see the session died. So that's actually one of the exercises that I had left for guys to do. So this was just checking out the execution, the process, like we just did, confirming that it's from where we want. Okay, so before I close that, let me just run it again, maybe something to show as based on the labs workflow. So if we have this shell running, as I said, this window pops up, and if we go to Process Hacker and we look at program 1, if we go to the network tab and again look at program 1, you can see that there is a connection to an IP 1.15, which is the attacker server here. And it's a TCP connection on port 8080, which is the port we're running for Metasploit or MSF wow, our wow, it just refused Metasploit server. Yeah, that. So you can, if you check the document, it tells you how to be able to use Process Hacker and Network to diagnose that. I don't use VirusTotal much to upload my test files because again, I believe VirusTotal shares the signatures with the AV vendors that are signed up onto its platform. So one option that Alim gave me was antiscan.me. So this serves similar purpose to VirusTotal, but does not give you as much insight. I mean, if you're doing blue teaming IR stuff, I highly recommend VirusTotal. If you're just doing the development, you don't want your binaries to get burnt and your code structures to get destroyed by AV vendors, then Anti-Scan.me is your better option. So basically, you just go to Anti-Scan.me. And that's how the interface looks like. You can just choose your file that you want to drop. It scans and you'll get a result of your scan. So, where is it? Where is it? Where is it? Where is it? We've gone too far. Oh shit, this is something else. Sorry. Yeah. So if you do that, I'll leave the user to go ahead and do this for themselves. If you go ahead and load your lab 2's program 1 executable, this is the one that has the unobfuscated clean MSF payload. So nothing has been changed. You will notice it will get flagged by a number of AV engines. When I did my test, it got flagged by 10 AV engines, which Defender was one of them. And you can even see it tries to tell what sort of payload it is. It detected it as a metapredator.b payload. So before we go to the next bit of this, I'd like you guys to compile yours, upload it to AntiScanMe. Just a side note, I've put it even there. Sometimes it says free scans are temporary unavailable. So just be patient, go back to it after a couple of minutes or an hour or so and try uploading your files. It might work. If not, just be a bit more patient. But then there's also note that there's a limit of only 5 uploads per day. That's on the free tier. So if you want to upload more, you then subscribe onto the platform. Yeah. So I'll give you guys 10 minutes to do that. It's 11:37. So 11:47, we get into the next lab, which is lab 3. Meanwhile, I can go back to the chat and just muck around with guys. To those who are not doing the labs. Okay. You didn't answer my staging question though. Sorry, I missed that question. Let me go through it. Can you set the permissions on remote memory region to read, write your shellcode and then set it to read? So basically the next shellcode injection, process injection bit will cover that sort of thing. Remember, this was not process injection. This was this shellcode injection within the current running process. So using process injection, one of the process injection techniques called remote thread suspended, we're actually going to implement this tactic of memory mapping to read-write, then changing it to page no access. So letting Defender scan it, seeing that it's clean, and then changing it back to read-write execute so that we can then execute our shellcode. So that's, I think, lab 5. I think it's lab 5. Attention here, clear doing this. That. Run auto run script to have it migrate Windows closes. We have a shell still, right? So that's why I was saying, Claudia, to answer your question on auto run script, I'm actually going to implement process injection within my own code. So we will actually be doing that ourselves manually. Virtual alloc read write. This will give you a pointer to your allocated memory. Then after read write X, then pointer. VirusTotal, definitely, as I said, even for red teamer, VirusTotal is still a go-to place for scanning your binaries to your memory. Source memory block to destination memory block. Check out for VirusTotal. Yeah, we're going to get to the syscalls at the end. Actually, I've re-implemented one of Jean-Francois's codes for Q user APC injection. So yeah, we'll be using dynamic invoke for the direct syscalls there. Samples to interesting AV parties, is that right? Yeah, that I believe so, that they send the samples to the AV engines that are registered onto it. Clean scan. Okay, Sumyajit, thank you for this. I've not checked this one out. In fact, now that we're here, let me just see what signatures it gets for our. Oh, it needs me to be registered onto it. Okay. Maybe another day then. For Retimobs, if you can find what an AVDR is, can't you just set up a copy of the defenses on the internet to prevent sample submissions and just do your testing? That's actually the strategy I tend to use. If I do find out what my client is running, then I do set up test environments and labs in my own playground, and definitely see how I can go about doing it there before actually doing it on the end client's network. Yes, so when it comes to EDR sort of things, definitely you're not going to get licenses. It's something even I have been looking for. The only, I think, EDR license that, which I'm not even too sure if I can call that an EDR, was Komodo. I actually used the free sign up process. I registered for an EDR license. It gave me a 30-day subscription, so I could actually play around with it for some time. So that's the only one I've done proper testing with. I have got opportunity to test with 2 other EDR vendors, but that was a client environment, so I'm not going to mention those. CrowdStrike on Black has me black. Jean, in fact, I saw your post, the one for Purple Shop the other day. Then how ETW on Microsoft EDR works is different. Something I need to even check out personally once I'm done with these workshops. Maybe I might be able to give you some more insight into those things and collab one of these days. I'll give guys another 2 more minutes and then we can proceed. How many of you have managed to compile your program for the lab 2 and have managed to get your reverse shell? Okay, at least one person has responded with done. Anybody else who has completed up to lab 2 compilation and execution to get your Metapeta session? Okay, with the interest of time and considering we have 5 more labs to go through, I'll speed up this as well. Okay, so let's just we've completed that and we'll move into the next bit. So as I mentioned, something I'll leave the audience to do is leverage Win32 API to minimize or keep this console program window hidden from the user. So that's one of the challenges in your lab guide as well. So the next lab, we're going to look at a bit on how AV work and how we can sort of modify our shellcode runner to bypass AV engines, or at least static scanning. So the default payload we generated got us detected by 10 AV engines. We'll see how we can try and reduce that number. So one of the ways we can do that is by bringing in a function that's not commonly used. And what happens is with this function, a lot of these AV engines are going to skip scanning through the rest of it. So when they see the virtual allocs number function being called, they tend to skip certain parts of the application, and therefore you can bypass or at least escape from getting detected on signatures on static scans. Another thing you can do is, sorry, I think I have a slide. Yeah, I have a slide missing. You can also insert a sleep time function in between your code. So this can help protect checking for when you're in a sandbox situation. So let's say your file has been sent to an AV vendor for analysis. If you have a sleep timer that says that if the code executes before the sleep timer is supposed to have completed, it knows that the program, whatever was trying to test the application, pushed the pointer to jump through the sleep cycle. So what that does is it tells the application that it's running in a sandbox. And if it's running in a sandbox, we can give it a function to exit and kill the rest of the execution of the process. Therefore, we bypass or escape sandbox detection, I believe. And then the third thing we can also do is use encryption. And for this workshop, I'm going to be using the exclusive OR encryption, or also known as XOR. So basically, it uses disjunction as a logical operation that outputs true when the inputs differ. So it's a technique that's commonly used by malware developers, and it's used a lot to bypass signature detection. So we can encrypt our actual MSF because you notice Windows Defender flagged directly on the payload because it even told us it's a Metasploit payload. So we know it's the payload, or at least I know it's the payload that's getting flagged. So what I can do is I can employ encryption to at least minimize that. So sorry, we'll go now to our labs. We go into our lab 3 folder. So in the lab 3 folder, we have 2 files. We have an encryptor.cs and we have the program.cs. So first we're going to work with the encryptor. So I've actually picked this file from Mauricio Velasco's repo on the DEFCON 27 C# workshop. It's part of my referenced list of repos, so definitely check it out. You learn a few other things about C# in there. So I've literally picked this code from there. The only thing I changed was, of course, the payload that I used to generate my shellcode. So once you've generated it, replace your shellcode in this region and put it in one line. And the rest of the code is basically taking the XOR function. This is the function that we're going to utilize. And you'll notice that, once you have your functions stated in the declared here, you can call the XOR function within your main and encrypt the entire byte that's passed through it, which will create this new XOR shellcode, which we can then print out to our console, which is here, the new shellcode to string. I mean, this is after it passes through the entire XOR. And we're going to be using a key. And for this example, we're using AfricaHackOn as the key. You can always go and change this key to whatever you want to use. For this example, we're using AfricaHackOn as the key to encrypt our shellcode. So this is the actual one that was given from MSF Venom. Just come and replace it here and save and compile the encryptor. So if once you do that, we'll just do CSC. Once you've done that, we can actually just run the file here, and we'll see we get the encrypted byte here for the new shellcode. So we'll take this now and replace it with the one in the program folder. So we'll come here, 3, open the program 3 that's there. And again, it gives a bit of information of what this file is going to do. So it does sandbox evasion and behavioral anomalies to bypass AV engines. It decrypts our XOR encrypted shellcode and injects it into the current process. So it's still doing the same thing, self-injecting into the current process using the same APIs, but just that we have now implemented a few techniques to sort of bypass sandbox detection and AV detection. So you can see the virtual allocs NAMA function being called from kernel 32 and the various variables that it requires, and the rest of the other things are the same. The only changes I've made is I've actually assigned these variables to these execute read write and commit reserve, so that I can just, instead of using them as a number here, I'm actually just using the variable that we've assigned it. As I said, you replace this segment of the XOR shellcode with what was spat out from the encryptor, which is this bit. Then we have the XOR decryption function. We declare this before the actual main part of the function. And here's where we can see I've put again a couple of console write lines just for debugging and reading purpose, and comments to understand what this part of the code is doing. So the virtual alloc X number is a rare and related API and attempts heuristic and behavioral bypasses. Then this is what I was talking about, the sleep cycle. So I put a sleep cycle that detects that if the code tries to execute in anything less than 2.5 seconds, it should exit. So thereby it will know that it was running in a sandbox, and it should throw a failed check command and exit out. If it does not, if it successfully goes through the entire sleep cycle, then it continues execution of our program. So we declare our string key, which is what we need to decrypt the encrypted shellcode. We have our encrypted shellcode being brought here using the XOR function, which was declared here. It will then now convert our shellcode back to something that's that the interpreter can use, and then using the same 3 Windows APIs, which are virtual alloc, partial copy, create thread, and write single object handle. It will then execute the decrypted shellcode. So basically, that's just a run through what this code does. So we can compile this. So as long as you've copied your shellcode into that file, if you've successfully done that, we can again test this out with so we have this 1155. We run this. So you can see it does the sandbox evasion, delaying, and we get our shell. So we know it's well and good, it works. Going to our lab guides. So we've done that, we've changed we can see the XOR function, we've gone through all this. Once I compile, I actually uploaded the new binary onto anti-scan me, and last time I got 10 detections. This time I got 8. And you notice that Windows Defender is now changed. It does not see the payload as MSF Venom, but it sees it as a different sort of course, a malicious file, but something different. It doesn't just cleanly see the Metasploit payload there. So yes, we have reduced the number of detections, but we're not completely home and dry. If you try enabling real-time protection and cloud delivery protection and copy that program file onto your desktop, you should see alerts popping. And if you try running the file with these enabled, you should definitely not get a Metasploit. If you do get one, wow, I don't know what you've done to your code, but that should definitely not work. We can quickly just test that and continue from there. So I'll just turn this on, close this one, we'll end that session, take this to our desktop. I can see everything is up and running. The moment I paste this, you should get that, yeah. So automatically we've already been detected, and it's the same exact name that we saw anti-scan me give. So yeah, that's a no-go. So from there, what can we do next? So we go back to our slides. So we've done XOR, we tested, we brought the detection down to a less number than 10. So let's look at simple process injection. Now, this is also some, I think there's, when I was looking at, there's a guy called Chirag Savla, also known as Exploit Coder. When I checked out his C# repo on process injection, he called it vanilla process injection, so something similar. It's just a clean, simple process injection technique, nothing too complex, not using major Windows 32 APIs that are out of unorthodox or out of the box sort of thing. So let's just see what it does. So some of the Windows 32 API that it calls is open process. So this opens it opens access to an existing process that you have rights and control over. So let's say if you are trying to inject payload into a process that's running at an administrative level or a higher authority than yours, that would not work. For you to be able to leverage process injection, you either need to have be in the same user context as yourself or lower. So you can always, if you're administrative, you can always inject into a user process, but I mean, you're an administrator, why not inject into an administrative process? But anyway, yeah, so if you're at a user level, you cannot inject into an administrative level process. You can only inject into a process that you have same rights as yourself. We will use another different, instead of virtual alloc, we're now going to use virtual alloc X function. This reserves, commits, and changes memory region of a specified process. So it's not now our current process, but the process we can declare and specify. We'll also use write process memory function. So this now writes the data of, so instead of marshal copy now, because we're writing to a specific process, we're going to leverage the write process memory API to then write our shellcode into the remote process that we're injecting into. Then we're going to create a remote thread in that process. And we're going to leverage once that thread is created and it runs, we should be able to get our shellcode. So this is just a snapshot, screenshots from our code repo for lab 4. So you can see that we need to leverage the open process function and then allocate memory. So we're going to create virtual alloc X as a reference, as a variable, which will then inject the shellcode, which has the length and size and everything, into that memory region, which is used when we use the write process memory. And from there, once the thread resumes, once we do the create remote thread, the shellcode should execute. So going back to our labs, we'll just go and we'll of course first disable this so it doesn't interfere with us. That, close this for now. So again, as mentioned, I've given a brief of the different Windows 32 APIs that we will need to be able to do this simple process injection. It's going to inject our shellcode into a newly spawned remote process. So this is where we declare the different functions that we want from the different DLLs. This is the unmanaged portion. We still have our XOR function, decryption function, and then we have still re-implemented our sandbox evasion and delay sleep tactics to avoid AV. And then we come now to our main function for the, our main program itself. So as you can see, we're going to spawn the notepad process in the background. Once we have this process, we will need the process ID because that's what we want to inject into. So that's where we get the process ID for the notepad process. And then we will use the open process to get a handle on that remote process. Then from there is when we can leverage of course, we'll use our key to decrypt our shellcode. And then we will leverage the write process memory to copy, using virtual alloc X that will now have our decrypted shellcode, then using write process memory to write our shellcode into that memory region, create that remote thread. And once that thread runs, it should get us our shellcode. Our shell. So basically that's just a run through this code. And again, once again, you need to swap out your shellcode, of course, with the one we get from encrypted.exe, which was the encryption one. As you can see, this is all in all of them. So it's something you'll have to be doing for all programs. Have that changed, compile it, and we can give it a run. So compiled. If we open now this, and this time we'll also monitor from Process Hacker what's happening when we launch this program one file. You can see the Metasploit is opened, Notepad, and we have a Notepad process running. If you go to network, we can see the Notepad process has the IP, so we know we have migrated and we've spawned this and migrated our shellcode into this process. To verify that, we can get into the session itself. And ps notepad.exe. You can see we're in the same process ID. So we have successfully migrated into the Notepad process. That should also get us to where we're supposed to be in the lab guide. So yeah, we've done that. We've compiled. You can always upload your file to Anti-Scan-Me, the new one we've compiled on Lab 4. When I did mine, it came back with 0 detections. So it was a woohoo moment for me. But when I tried running it with real-time protection on, and that's just without cloud delivery protection, I did get, I think it sent the stager. It injected into Notepad. It did send the stager. Yeah, so with just real-time protection turned on, it should give us our shell, another shell. So let's just background this one. Go back to this, turn on the real-time protection, but I'm not turning on cloud delivery protection, and I'll show what also that does. So if I run this, We have a notepad spawned, a new notepad has spawned, and we do have our Metasploit session. And if we do sessions by I5, we are 2920. That's basically this process. So we've managed to do that, and that's with real-time protection turned on. But that also tells you that how important cloud delivery protection is in when you're using Microsoft Defender, because the moment I turn this on and I now run the same thing, this time I don't think it will work. Oh, it worked. Okay, that's weird. Okay, I can see that and that. So you notice the notepad that's there now does not have a connection. It's just running. You can see the input output bit. And this is where I'm saying, let's see, there was no flags. So that's interesting. And that's turned on. That's interesting. Let's see. This is still, why is this run? Ah, okay, I get what happened. It jumped from, okay, so let me just do this and delete, let's see other sessions that I have. So we should not have any notepad processes running. And you can see they're all still hanging here. So this is another bad issue with running it through the way I've done it through the simple process injection. It will always have the notepad program running here. So even if you terminate on Metasploit, it still doesn't end it. Here, the session just runs. So now I don't have anything running. I have everything turned on. If I run this. Okay, I don't know what magic I've done, but it's not supposed to work that way. Ideally, once you have cloud delivery protection turned on, it caught the process trying to do something malicious. So you can see the behavior, and this is what flagged for me when I was running the program. And you can see it gets blocked, and the Metasploit session actually dies immediately once detection happens. So I'm not too sure why it's not happening on my side currently, but I believe it should happen this way on your end. Maybe somebody can verify if anyone is trying the labs as we are going along. Okay, let me just quickly read what I've missed. Yeah. This is not the AD lab by Lim, but that's the workshop one. There's actually, I think this to answer Karan's question about local scanners, I believe there's like some PowerShell scripts you can run that will have a list of AV signatures within it. Then you can verify your binary against multiple AV engines without actually having to use an online platform. I've not used those things before, but definitely I know there's things like that out there. Hopefully, okay, that's all okay. Did anybody try this last bit of the lab where they turned on AV on lab 4. And got similar results to this rather than what I was getting. Okay, not yet. Anyone who had their labs up and running and tried lab 4 with Defender enabled? Okay, I guess we'll move from there, but there's a challenge for everyone. Once you're done with lab 4 compiling and you have your, you're able to run Metasploit shell when Defender is off. Another thing you can try and do is, instead of injecting into Notepad, try and look for a different application like calculator and see if you can inject into that instead. So that I'll leave it to the user to try and do. So that was my process injection result. So yeah, so this is the challenge. I was saying, instead of injecting into Notepad, try and see if you can inject into calculator. That's just for your own purposes. And ideally, when you're doing process injection, you'd not be spawning Notepad. I mean, that's already like why would Notepad be running in the background? So look at injecting into legit processes that are there. Like, for what we're doing is because we're spawning a new process. So of course, it will show the thing. It will show the application that you're spawning, but you can also look at opening a new explorer.exe and injecting into that as well and hiding in plain sight then. So lab 5 is going to be using the remote thread suspended injection technique. So this is where, like someone had earlier mentioned, where you're changing the memory region properties for the newly spawned process to not have read write execute, but just have read execute, and then change the memory space address to a different writes. Maybe the example I'm going to use is going to use the page no access. So when a scan is done by Defender on that new process, it will see there's nothing malicious in the mapped memory regions. So once it has finished the scan, it will allow us to continue interacting with that thread, and we can change back the memory region to read write execute, inject our shellcode, and resume the thread and have our shellcode executed. So basically, this is sort of how it would look. We have our target process that's spawned. We'll spawn a new thread, put it into a suspended state, change the memory protection rights from read write execute to page no access. Give it a sleep time for a couple of seconds for Defender or any AV engine to scan it. Turn back that memory location to a read write execute. Inject our shellcode into that region and resume the thread for us to get our shell. So some of the Windows 32 API functions we're going to leverage is the resume thread. So it decrements as threads suspend count. When the suspend count is decremented to 0, the execution of the thread is resumed. It just basically has one parameter it needs. The rest of them, we already have it because we were using that in the it's the same what do you call it, functions that we need. We just how we're going to re-implement it is in a slightly different way. So let's just open it and we'll be able to read about it briefly. So yeah, so you can see if we compare this one with the previous one. So the previous one was inject shellcode into a newly spawned remote process, while this one does inject shellcode into a newly spawned remote process, flips the memory protection to page no access. After a short sleep, waiting for possible AV scan to finish, flipped back to page execute read write. Sorry about the thing there. And then it will use the thread execution. It will do the thread execution via resume thread. So if you look at the kernel 32 APIs that we need, this one had open process, virtual alloc X, write process memory, create remote thread. While this one has the same open process, virtual alloc X, write process memory, but then we call virtual protect X again because we want to change the memory region. And then we're going to use the create remote thread and resume thread to run the code. So we just bring the new, as I said, in the comments, you'll always, for whatever we've already previously used, there's not going to be any comments. For anything that is new, any new Windows 32 API that we need, like we saw, we needed just resume thread. I've added the link to the Microsoft documents, so you can read up on it. Again, it follows the same flow. There's an XOR decryption function. We have the initial AV bypass, AV check bypasses, as well as the sandbox checking bypass. And then we're going to spawn the notepad process, get a handle on the process ID for that newly spawned process, then decrypt our shellcode, and then we'll start that whole process of changing the memory region. So the first thing we're going to do is, let me just open this larger. So the first one, it sets the memory to be allocated to the remote process. Then the next time virtual alloc X is called, it then sets the memory region to page no access memory region. It creates the remote thread in a suspended state. And then there's a sleep cycle that's called. So usually this will now mean that once this suspended thread is now just hanging there, the antivirus is going to scan through it and try and look for any malicious looking memory regions, especially with read, write, execute. If it does not see anything like that, it will be fine with it and end. Then we can go back and change that memory region back from page no access to page read, write, execute, and then resume the thread, which will then obviously spawn our shell, our Metasploit session. So you can go ahead and compile this. So this is lab 5. We have successfully compiled that. This. We have our program 1219. Then Kali. One session running. If you see, you should only have one notepad process. So that's the one that's there. So now we'll use the remote thread process to inject. And AV should be turned off, sorry. Just to make sure it doesn't give us problems. If I run this, it does the delay, sleeps, and that suspended process, waits for Defender to check the suspended thread. If Defender sees nothing malicious, it resumes thread. The moment it resumes, we have our Metasploit session, and we have a new notepad spawned. I think it's page 2580. If I go into yeah, it's 2580. So we have spawned into this new notepad process. And this time, if I exit, you'll notice the process is still there running, but there is no more connection. So it will leave this as a marker. So this is not one of the best process injection techniques to use, because the way I've coded it, it's not about the technique, it may be the way I have programmed it. It leaves a spawn process running there. So it can still be sort of like an indicator of compromise. So it's not the ideal program to use. Or I mean the ideal solution for process injection to use. and go back to the labs to make sure that we are doing the right things. So we've compiled, we uploaded. If you upload that one, it should give us similar results to the other ones of 0 detections, because we're still using the same sort of things, just that we've added one more Win32 API. But yet again, when I enabled Defender and ran this, it got again similar things. Let me see if this one will do the same result. I'm going to take that. Okay, I don't know why that is stuck. I'll just rename this to something else. And enable real-time protection, enable cloud delivery protection, copy this here. If I do a scan with Microsoft Defender, we have 0 threads found. And if I try running it, see what happens. Oh, now we got detected. So there we go. And you can see it has even seen it's the Metasploit shellcode. So it has detected our shellcode once it got decrypted. And you notice there was no connection on this end. If we come and see if there were any notepad processes spawned, we have this 22, but there's no Metasploit session running with it. This technique will not really give us the best result. The next thing we're going to look at now with this technique, slightly different. Okay, cool. So coming back to the Q user APC process injection, this is going to leverage what's known as the Q APC function calls. APC stands for asynchronous procedural calls. And as the name states, it's going to have procedural calls running in a queue along the other thread, within the thread that has been, it's been requested to run in. The only thing is it's going to run as a user-based queue insertion in that remote thread. So some of the Win32 API functions that we will need to leverage is the create process. So now this is different from how we were creating the process earlier. We're actually going to leverage Win32 API and the different parameters that it needs to be supplied for us to be able to create a new process, which can be the notepad, calc, or whatever other process we want to open. Then the other thing we need is the open thread function. And this gives us access to an already existing thread that's out there. So in this case, as I said, if you're going for the notepad, it would get that. And then we also need to leverage the Q user APC function, which allows us to create those user mode asynchronous procedural calls into that thread, which once the thread resumes, it will then execute our shellcode and get a reverse shell. So we'll go back to our lab document. As before, we can go and we'll just read through the code slightly to just understand it, what it's trying to do. So you can see these are the different, it still requires certain API calls that we have already used before, like the virtual alloc X and the write process memory. But as I said, we have the new one called create process, open thread, and Q user APC. So if we go through the code, you'll see the mappings for the unmanaged delegations. Then we have our standard environment checks and sleep cycle. We have the decryption of the XOR function using our key and the new shell that we get. Now, this is where I was saying this is what we use instead of the way we previously started the process, which was using process P and spawning it using process.info. We're going to use the create process function, as you can see here, to open Notepad. So we specify the location of notepad.exe and the different parameters. And since we want to create it in a suspended state, suspended uses the value 0x0444. You can go through the MSDN documentation. So you can use the okay, I don't know who's yeah. So coming back, I said go through the process creation documentation, and you'll get to understand the different values and what they do. So for suspend, this is the value, the hex value that's required to assign it suspended state. Then we again use virtual x to create that memory region where we want to inject our shellcode into. We will use the write process memory function to inject our shellcode into that region. Then we will use the virtual protect x again to change the protection that memory region, for that the protection for that memory region we had specified. And then we use the QAPC function. If you hear a dog, sorry, that's my dog. It's his lunchtime, so he's getting his food. Yeah, so QUseAPC function is then called to then execute the T pointer value, which is the open thread. And once the, to inject that value in the open thread. And then once the resume thread happens, it will run our shellcode. So we can go ahead and compile this. And of course, before you compile, make sure you've swapped out your shellcode to the one generated by Encryptor. Once that is done, you can go ahead and test. Yo, what the fuck is wrong with this guy? Cool. So getting back, once you've compiled, we can try and run our code and see if we get a shell. Right now, we'll actually do it with because of time, it's already 12. Actually, we have time. So just turn this off. Settings, turn off real-time protection, turn off cloud delivery. If I run this, we have process hacker running. We can see if a new notepad will be spawned. You can see 7188 has spawned. Interpreter has come, and we have a connection as 7188. If I come here, it should be 7188, which is this one. Now, this time, if I exit, you'll notice the actual application event. And so with the QUseAPC, it's more discrete in also how it handles the spawned process, because of we're using the create process function, not the process startup function. So having those two in mind, they will tell you also what sort of indicators you can end up leaving on your target. So remember, these ones we spawned with the startup process information. So if you do sessions and I go into sessions 7, and I exit from this, you'll notice the notepad process is still there, but the IO output has ended. So there's no more shellcode running in here, or no more shell running in there. So I actually like the QUser APC process injection technique. And I'll also showcase why that. So if you go by the lab manuals, this is QUser APC. Yeah, if you send your file up to anti-scan me, you'll notice it has 0 detections. So that already is a plus, and we will actually try and test this now. We'll rename this to lab 6 and copy it again to the desktop like the previous one we did. I don't know why this is still there. It's supposed to have been deleted. Yes, detection history. Yes. Yeah, lab 5, I want to remove you. Refresh. Yep, they're all gone. Paste. So we have lab 6 there. And I'll just clear this out. If I do sessions, I should not have any sessions running. Open process hacker to see what's happening on this side and make sure cloud delivery protection and everything is turned on. So that's turned on, cloud delivery is turned on. So we're running it in a fully protected mode. We scan the file. 0 threats found. No notepad process is running. Execute. Let's see what happens. And this time we have AV turned on. So let's see if we get detected this time around. And you notice we have notepad spawned, shellcode executed, real-time protection is turned on, no messages from Defender. So we've literally bypassed antivirus, fully protected. You can see what the updates are, signatures. So that's today at 5:51 in the morning. So we have almost fully up to date, at least it's recently updated. And we have a Metasploit session. 10 speed, we can see we're 5680, which is the notepad process. So we've technically fully bypassed a fully updated Windows Defender engine. That brings us to the end of lab 6. Yeah, so I think the next, so what we're going to do is we're going to see if there was an EDR running on this machine that was leveraging userland hooking. Now I'll go back to our slides to give a bit of an explanation on that. So what is userland hooks? Now, when we looked at the way .NET works and tries to call the Win32 APIs, we saw that we'd have to, I would say, borrow functionality from unmanaged DLLs. So like we've been using kernel 32 to inject, to get functions from the Windows API, like the create remote thread, virtual alloc X, and all these things. These are all running at the kernel level. And since we have used the kernel 32 DLL, we can map out those functions and give our application those capabilities. But now, what if you have an EDR installed that actually uses userland hooking on the environment? So by userland hooking, and I'll quote Jean-Francois again on this one. I know he's not there in the chat, but I mean in the session, but he was here earlier, and he's the one who came up with this thing called EDRs or hookers. Basically, if you look at this slide, this is what an EDR does. And I actually borrowed this from Jean-Francois's blog post on NVisio on bypassing EDRs. So when an application is leveraging a an API that needs to be pulled in from kernel 32, kernel 32 will then send that request. So in this example, it's looking for the NT-read virtual memory into the NT-DLL DLL, and then create the syscall into the kernel region. But if an EDR is hooked into this NT-DLL process, if we try and request for a syscall that is malicious, or the EDR knows, or the EDR vendor knows is malicious, it can block the syscall from being pulled, and therefore block the execution of our application. So that's basically how EDRs that hook work. So they'll either, then the lower they can hook into, and I think NTDLL is the lowest lowest managed DLL that we have access to in user land mode. Because remember, we cannot directly communicate to the kernel, and therefore we need to leverage these DLLs, especially NTDLL for sure, because that's the last one before you get into the kernel mode. So if an EDR is hooked into that lowest tier, they will see your syscall, even if it's coming from the kernel 32 side. And if they see it as malicious or something that would be weaponized, or is known to be a weaponized syscall, especially if it's combined in the same thread function or something like that, it will definitely flag and block execution of our payload. So a little bit of a difference between endpoint protection and AV. AV work mainly on byte matching and hashing, sandboxing, and of course, Amsi to leverage on in-memory analysis. But it has poor to no endpoint visibility. As we saw, we were successfully able to get a Metasploit session with a fully updated Windows Defender running on that machine. If we had something like an EDR running, EDRs look at detection instead of prevention. So they will detect, they will look at what are the type of syscalls, or what is the behavior of this application. Now, sometimes it'll be like, why is this application spawning another application? If it sees that in the context of process injection, that can be a known bad. And if it sees that as if it's signed off as a known bad, that thread execution gets blocked or destroyed. So in essence, no shellcode. It also responses about malicious behavior. So there are also some form of remediation activities that an EDR can do for a client. And it also collects telemetry that one can use for threat hunting. Because of all these sort of alerts and logs that an EDR will create, it becomes easy for somebody on the blue side or an incident responder to then be able to start up some threat hunting program. It usually, these EDRs will end up hooking at a very high process level. So they give a lot of visibility into what is happening on the endpoints. This should not have been, this should have been EDR. Changing things on the fly. Okay, so basically that's the end of our boring slideshows. And we can go back to the last bit of the exercises, which is the last lab. We still have one more exercise in lab 6, and then we have lab 7 to complete. So in this one, we're going to leverage a tool called Silent Strike. It's by a fellow called, he goes, I think it's Ethical Chaos on Twitter. I don't know his real human names, but yeah, he has some interesting research he does in how EDRs work and how the hooking functionality works in EDRs. And he built a tool called Silent Strike that one can use to sort of mimic how an EDR works by injecting its DLL into a process that you want to monitor. And once you have that set up, if you try leveraging anything that is going to run in the process that's being monitored, and it sees those malicious API calls, it will immediately alert and terminate the thread from running. So to do this, you need to open command prompt as an administrator, because as I said, you have to inject into the process at a high integrity, and simply running these commands in the newly opened command prompt in the directory where Silent Strike is. You should have Silent Strike running sort of like this, where you'll have it saying listening for following processes, and we'll particularly be looking into Notepad because all our code so far we're trying to inject into Notepad. So we want to see what sort of syscalls is Notepad doing. So with that, when Silent Strike is running, you can try executing program 1. So let's just quickly try do that here. So we'll just run this lab 6, which is our program 1 again, but once Silent Strike is running, to run this as administrator. So I had for the people who used my VM, I'd kept Silent Strike on the desktop, but then for this particular demo, I've created a copy of it in the C directory. So if I do C and directory, you'll see there's a Silent Strike. So I've just basically moved this into the C directory, and we'll now go into that. And we will execute Silent Strike. And say we want to monitor the Notepad process, and we want to inject the Silent Strike DLL. So for this, you have to give the full path of the DLL. You can see that's injected, and it's looking and it's monitoring into any newly spawned Notepad processes. Let's see this side by side with that. Let's run this. So it's decrypting. If we see Notepad, we'll see that it will try and inject. Oh, it actually, and there we go. It is detected, and you can see Silent Strike has caught us trying to load our shellcode. So even if the real-time protection and AV is turned on, Silent Strike is in this scenario playing the role of an EDR. And you can see it saying you've been a naughty little hacker, terminating program. I would really recommend you to go and check out the Silent Strike repo on GitHub. Unfortunately, there's no releases available for it, so you have to download and you have to clone the repo and compile it from source for you to have your executable and DLL. That's why I'd actually put this one on these VMs so that people don't need to recompile the program and just use what's there already available. And you can see this there's no metapeta session open because it has actually terminated our thread. If you go to see Notepad, we should be injecting into 6692. So the moment I click OK, it should terminate and kill that. And you can see the metapeta session has died. So that's how, in essence, userland hooking for EDRs work. How, as a threat actor, as a red teamer, can be bypass or go around userland hooks. Now that's where, if you've been seeing the chats, there was a lot of talk of dynamic invocation. So we've been leveraging the platform invocation to do our unmanaged code execution. But now we can leverage something known as dynamic invoke to be able to call for those syscalls that we need directly from kernel space, but without having to use the kernel 32 DLL or NT-DLL. So literally, if we're looking at this execution flow as per this, we will bypass this hooking, and instead of calling our read process memory from kernel 32, we will map out the syscall value based on the syscall table for that specific read process memory or NT read virtual memory function that we need. Therefore, if our application already has the function mapped, it does not need to leverage these DLLs and can directly go into this kernel region and get us our this thing, I mean, it will get us our connection back into this network. So basically it will bypass this whole process and directly use the syscall table to pull our API and execute our shellcode, and with the same APIs that we needed. That means we're not going to change the APIs that we needed in the Q user APC. That's these ones: the create process, virtual unlock, write process memory, open thread, and these. So to do this, we can just open our final lab. That's lab 7. And we'll open this now. As I mentioned, this is a huge file because we're now literally mapping the syscall values to the actual functions that we need. So there is this anti-status syscall. You can see it's an undocumented enum, and it has all the various like syscall values attached to them, and we can now use this and the syscalls for write open process, write process memory, create thread, and all those things, map them into these delegates. And once we have the delegate functions, as you can see here, we can then call for those in our actual program. So our program still sits at the top here. So this time I kept our program. As you can see, the static main is here. So it just does the same things that we've been doing, but this time how we're calling our application, instead of just directly how we were doing before in terms of just saying, create process and giving it the variable values that it needs, we have to use delegates to call for those specific Win32 functions. So I've taken, as I mentioned, this is the Q user APC platform invoke based process injection that bypasses AV but does not bypass EDR. Whereas this one is now using the whole dynamic process injection, dynamic invocation to be able to do process injection. And this should also bypass AV as well as now EDRs, because now we're making direct system calls. The only kernel 32 DLL call function calls that we are actually leveraging are sleep and virtual unlock x numa, and these are not malicious functions. So basically EDR should not flag on these as malicious. Our Q user APC, our virtual unlock x, create process, these are now known as malicious Win32 APIs. So EDRs will definitely flag when they start seeing a process requesting for these sort of APIs. So to do the final lab, we will compile our code. To 7. And we'll compile this. CSV.exe1. If all goes well, it's oh, and again, as always, swap out your shellcode over here so that it's correct to your lab. Compile it and then execute. So again, we have lab 7 here. Call this lab 7. And we have AV turned on. We have silent strike still listening. And remember, this is supposed to do the same functionality as lab 6, but using syscalls instead of mapping to kernel 32 DLL and requesting for the syscalls through there. So to do that, I'll just background this. If I run lab 7 now with silent strike there, we should see a new notepad. Let me just keep process hacker close by so we can see what's happening. So we know this is the current one. This is this one. Let's run this and see if we can bypass silent strike. And you can see Notepad is open. Oh, and it has actually picked us. Wow. Wow, that is very interesting. Huh. I tried this earlier. Let me see my lab notes. Because after I recompiled the new one, it had more detections. This is the one with the dynamic invocation. But when I ran it here, you can see it opened a new Metasploit 26660. It had injected into that and nothing happened. And I had a full-on Metasploit session. So I don't know, maybe this is the shortcomings of the demo codes. I mean, we only have 10 minutes remaining, so I'm not going to redo this, but you sort of get an idea of what you're meant to have achieved by the time you complete lab 7, is to be able to even bypass userland hooking through userland hooking that would be looking at process injection techniques, especially for the syscalls that would require for Q-user APC injection. With that, we come to the end of the labs. And as I mentioned, there is some challenges as well for guys to do. I would have wanted guys to modify that Cradle PS1 file to inject our newly created binary directly into memory. So you can either try lab 6 or lab 7, depends on you, and see if you can reflectively inject your application into memory and use PowerShell to get a Metasploit session. If you get any alerts, you might be because of Amsi, and I recommend going to read Secure This Shit's blog on the various types of Amsi that are there and how to bypass them. As I mentioned, there's Amsi for PowerShell, and there's Amsi running in the full context of a thread. So you might need to be able, usually the one that detects you in a thread is the one that sees .NET functionality. So you'll have to look at how to bypass Amsi in the .NET framework or way. Yeah. And with that, I believe we should be at the end of the workshop. Whew. Good. Do we have any questions?
That was that was a lot to take in. Got to a point I was lost, but I'm saying let me just continue watching. And it's very enlightening to see some of these details that you've given there. I have to go through all the notes and the links that you've shared and stuff, and re-watch this video, so this recording, to understand in depth exactly how some of these things get to be done. So I think there's a few questions that a few comments that I'm seeing from the chat. When someone like Vince Trun tells you sweet, that means it's gone well.
I hope so.
yeah, it has, in my opinion, and he's a guru as well in this area of yours. So it's really enlightening. And what I want to say is thank you very much for being able to even do this. I'm seeing a question here asking if there are any resources which beginners can use to learn C# for malware dev and AV bypass.
Okay, so if you go to the link I'd given for the entire workshop, under the acknowledgements section, there are links to a couple of people and their GitHub repos. I recommend, these guys usually work in C#. So check out their repos because they'll have things you can read through. And if you understand scripting, C# is not very difficult. It's pretty much just putting your code in a structured format. So you can read through the code and try and understand what it's trying to do. As I mentioned, I'm not personally a C# developer. My background comes from C++, but this has been pretty easy to do so far. So I'm enjoying it. It's just a learning experience because some guys even asked why C# when you can go into a lower programming language like C++ is at a lower level. So this was all just for me, a personal learning experience and sharing with the community what my experience is while doing these things.
Actually, the last time when you and I were working on something like this and made this discussion, I'm not a C# programmer as well, but I was able to understand because there's just very few editing to be done.
Yeah.
And so I don't think anybody has to be a pro, but just need to follow these instructions and understand code. So far as you understand code, I think this should be pretty straightforward. Somebody's saying they need a group for networking. There's already a lot of groups that we have created. I don't think another one will be necessary right now. But keep watching out for the AfricaHackOn Twitter pages, LinkedIn, and various pages that are there. We will be basically sharing a lot of information. And like I said, there'll be in-person meetups as well from next year. And just to watch out for that. Good to recognize Alim also, who is here. Somebody also known in the entire community. So if there are no more questions, Labu, I believe your link, your profile is out there. People can look for you, and people can ask questions more than this. And I'll encourage you all to actually go for that. Thank you very much, and I will close this session now.
So before we go, I think there were some questions that were asked.
Okay.
I can see Claudius had asked, can one use AES? Yes, you can use AES. Just because of speed and time for the entire workshop, I didn't go the route of going through AES. But if you go through Mauricio's DEFCON 27 workshop for C#, he also talks about the one where I got the XOR code from. He also has an encryptor for AES. So you can actually go and re-implement everything that I've shown you with the AES encryption function instead. So something you can pick up as a challenge for yourself. Vince has asked, why not de-invoke everything? Ideally, that would be the perfect thing to do. I mean, this was to teach people of how to start off from C# and just understand the Win32 APIs that you need, and then get into dynamic invocation. So ideally, I would recommend as many people to look into the re-implementation of tactics through dynamic invocation. Rastamouse has an interest because I think de-invoke was brought about by FuzzySec and the Wover, and Rastamouse has now set up a wiki page for the de-invoke platform. So you can also go and check out the various syscalls and how to re-implement them using de-invoke through that website. And let's see questions. What tools would you use to make malware delivery? You can use macros in Word and Excel. So I think there was a brief discussion on the chat about that earlier. So look into that using VBS, gadget to JScript. There are lots of things you can use to run your malicious code remotely through Maldocs. Yeah, just go and search on Maldocs. There'll be various techniques out there. Share link to any other groups, that's fine. Thank yous. You're most welcome to everyone who said thank you. What was the AD Labs mentioned earlier? Alim is in the chat. Alim, could you drop the link to the Discord, or should I do that? Actually, let me just do that. I think I have it here.
I think you can share the link.
Yeah, let me just quick. I have it already here. I can just drop it on the. So to those who are looking into get into AD pen testing or red teaming, definitely check out these labs by Alim. Fantastic headaches, but I trust me, you'll learn a lot through them.
If anyone ever finishes Alim's labs, I congratulate them. Even if they just and by the way, guys, tonight there'll be the final CTF challenge. That's going to be physical. So for the top 30, the top 10 teams that actually won, that is going to be tonight. I don't know if we will live stream it, maybe not, but it's going to be heated. We'll be sharing all of the information in the social media pages, so you can actually watch out for those as well. And actually, we'll be having sessions where Alim will come take us through AD, pen test, and everything in the future, in the very near future. But that will be physical. So again, watch out for the registration processes, the various pages for AfricaHackOn. So again, I thank you very much, Margaret. Always been an awesome working with you, and every time you show up, you show up. And I don't take this for granted. So I would like to close this now. I like to be on time, so I don't want to go past the schedule that has been set. And see you all very soon. By the way, guys, don't forget to register for the how do you call it? AfricaHackOn session tomorrow. Again, check the social media pages. All of them are there. Let me see if I can get that link quickly. We have amazing speakers who are going to be talking to us tomorrow. So make sure you don't get to miss out. Let's see.
Should I end the meeting?
Yes, please. So I think we can end it there. Thank you very much, everyone. And thank you so much, Shehats, for taking up the hosting of this.
You're welcome. We're glad to help.
You're welcome. You're welcome. Thank you.
Goodbye, everyone.
Goodbye.
Bye. Thanks everyone for attending.